Hey everybody, welcome back to another fun and exciting pre-calculus class. Today we'll be jumping into chapter number 9 in your book. Chapter number 9 is on page 176. And you'll see here we're going to be talking about complex numbers in this chapter and de Moivre's theorem. I'm not a French speaker, so I think I did that fairly well for never having a day of French in my life. If you think that I said it wrong, then you can do your research and maybe send me a message and tell me how to say it right, okay? But de moivre. I had a friend that spoke French and told me that that's how to say it. So that's what we're going to go with. All right. So lesson 9.1 is on page 176, and we're going to be talking about imaginary and complex numbers. Now, you may remember this from last year, Algebra 2, whenever you had that, where you learned about imaginary numbers. So maybe this will kind of be a refresh for you, or maybe you don't remember this at all, or maybe the book that you used didn't even have it. So let's talk about what are imaginary numbers, how do they work, what does it look like, all that good stuff. So you can be there on page 176. You'll see some different things here. You'll see some definitions. You'll see some tables. I'm going to switch over to my computer so that you can see what I have written down. I've got a definition of imaginary numbers here. It's the square root of a negative number. The square root of a negative number. Now, you might say there's no such thing as a square root of a negative number. I know, right? That's why they call it imaginary, because we imagine that it's true. It's not reality. It's not a real number. It's an imaginary number. Okay, so yes, there's no such thing as a square root of a negative number. But in order for us to solve these problems, we're going to need to do something and just kind of make this up as we go and use these imaginary numbers. Now, the symbol for the imaginary number is the letter I, and it's a letter I kind of like in italics, or it's a little bit of a funny looking I. So it's not just your regular standard I that you're going to see. If you see it in italics, then you know, okay, we're dealing with an imaginary number. So it looks kind of like this. All right, so over here I have some different quantities of the imaginary number. Or in other words, we have like not forms, but different ways to write the imaginary number. You'll see what I mean in a second. We'll just kind of progress from here. Let me show you real quick before I show you this. Let's say we have the square root of -9, okay? Well, we know there's no such thing, but if we take the square root and we break it up, so we could say, well, that equals the square root of -1 times the square root of 9. In other words, we're taking this negative out by factoring out a -1. That way we can solve this. All right, so here's what we get. This square root of 9 is going to give us 3. This right here actually gives us, that's our imaginary number. The square root of -1 is imaginary. So we end up with imaginary times 3. With that in mind, sometimes when we're solving these, we are going to get not just I3, we're going to get I3 times I3 or something, because we have to multiply. We have to do operations with these, right? Multiply, divide. And sometimes when you do that, you're going to get things like I squared, I cubed, I to the fourth, because you can multiply I times I, right? I times I equals I squared. The same rules would apply that apply in, regular mathematics. So what do we do when we get these things like I squared? What does that mean? Well, in your book, there's a little table, right? That was on page 176. You may be looking at that right now. I've kind of written that table right here. And what we have is the first one is that I equals I. Some of you are like, well, yeah, of course I equals I. And you're right, of course it does, right? But we need to start with that so we kind of put our baseline on there, and then we can talk about what the other ones equal. Look, I squared, the second one, I squared equals what? -1. So in other words, if you have a problem that multiplies two imaginary numbers together and you end up with I squared 7, for example, We're not done with this because we can substitute this I squared with this -1. So -1 times 7, we do it and we get -7. That would be my answer. Do not leave your answer as I squared 7. That's not going to be the correct answer. Okay, so the next one is I cubed. Okay, and I cubed equals -I. So again, if you have, let's say that you have I cubed 7. Well, this is not the answer to your problem. The answer to your problem is to convert this to -I7. This would be the proper answer for that problem. Okay, the last one is I to the 4th equals 1. I to the 4th equals 1. So whenever you get I to the 4th, just convert it over to the number 1. You need to memorize this chart. This is a very important chart for you at this level. Most of you probably already have it memorized. You did it in Algebra 2. Maybe some of you did not. All right, so let's talk about, well, what if it's I to the 5th, for example? You don't have anything with I to the 5th, and you're correct. So what if we get I to the 5th? Here's what you do. The trick is you take this exponent, whatever it is, and you divide it by 4. So 5 divided by 4, and we get a 1, and we get a remainder of 1. Okay? So whatever that remainder is, that's the one that you go to. Okay, so this is technically I to the 1, right? The first one is I to the 1, I to the 2, I to the 3, I to the 4. Okay? So you go to, okay, I have a remainder of 1, so this actually simplifies to I1, and so that is going to equal I. So I5 equals I. Why? Because we pull out the 4. We divide it by 4 because there's only 4 variations of what I can equal. I can only equal one of these 4 things, okay? I can equal I squared can equal -1, I3 or I cubed can equal -I, and I to the 4th can equal 1. After that, it just resets. It just keeps restarting. So there's only 4 possible options. So you can do it with anything. You could do it with I to the, let's say I to the 22nd, for example. Well, what is that? I don't know. Well, take the 22, take the exponent, and divide it by 4. So that's going to go in there 5 times 20, and we're going to get our remainder is going to be 2, right? So we go over here to the remainder 2, I, and we get -1. So I to the 22 equals -1. That would be our answer in that one. We'll practice that a little bit more later on. Look down here. It says always extract the I before simplifying the radical. So don't do this. This is a no-no, okay? So don't take this and say, oh, okay, I'm just going to go ahead and combine this, because we've done this before, times -9, okay? And so then you're like, okay, I'm just going to multiply this now, and so I'm going to get -36. So I'm just going to take out my I, so -1. And then take out my square root of 6, and then I'm going to get, okay, so this one's I, and this one's 6, I6, right? No, 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 you did it all wrong, okay? Why did you do it wrong? You didn't really break any rules of mathematics, did you? Well, none that we've learned so far. You didn't break anything that we've learned so far. That's how we would do that typically. Let's write that bad answer up at the top. So I6, we said that that's the bad answer, right? So we're going to leave that there. I'm going to put an X mark out next to it because I want to show you what you're actually supposed to get and show you why that's the wrong answer, okay? So here's what we do. It says this is the new rule that we're learning. So this is the new mathematical rule that we can't break. What's the rule? We always extract the I before simplifying. All right, so watch this. We're going to extract the I times square root of 4 times extract the I, -1 again, times square root of 9. So we extracted two i's. We did not extract one I. Both of those were imaginary, not just one. Okay, this was imaginary and this was imaginary. So always extract that before you start simplifying. So here we have I, and this is where, remember I said that we're going to get these that have like I squareds and I cubes and things like that. Times 2 times I times 3. So now how do we do this? Well, we can combine our I times our I. This is like the variables together. And so we're going to get I squared times 2 times 3 is going to be 6. Well, remember that I squared is, go back to this one, I squared is -1, right? So what we're going to get is -1 times 6. -1 times 6 is -6. Our answer is not I6, it's -6. Okay? So the way that we did it first gave us I6, and that's the wrong way. The way that we did it second, by taking out, extracting the I, the imaginary, before we simplify the radical, gives us -6. So these are two very different answers. So sometimes imaginary equations can give you real answers. So yeah, that's using this. Obviously, if you're going to get an I squared, it's going to be real. And if you're going to get an I to the 4th, it's going to be real. When you get an I to the 1 or just I, then it's going to be imaginary. And if you ever get an I cubed, it's going to be an imaginary, negative imaginary, but imaginary. All right, let's practice a couple more of these. Here is I16. What are we going to do with I16? Remember our chart, we have 4 different possibilities. We take the 16, we divide it by 4, and that gives us 4, and that gives us 16. We get 0. Our remainder is 0. Well, you might go back up here and you might say, oh, Mr. Steve, you didn't tell us what this remainder 0 was. So you only told us what the remainder 1, the remainder 2, the remainder 3, the remainder 4. Well, look at I4, right? So if we take 4 divided by 4, we get a remainder of 0. So this one right here is your remainder 0. So this would be remainder 1s, remainder 2s, remainder 3s, and then this last one here is actually remainder 0. Okay? So if you want to kind of write that, if you want to kind of add that to your chart, those remainders, 1, 2, 3, and then 0. So anything that you get a remainder 0 is going to be this one right here. It's going to be the number 1. So here we got a remainder 0. And so this one is going to equal 1. That's it. Okay. Next, I30. We're just going to do the same thing. 30 divided by 4 is going to give us, well, 30 goes into 4 is 7 times, and 7 times is 28, and that's going to give us a remainder 2. So you can scan back up to your chart again. What are the remainder 2's? Remainder 2's give us -1. So the answer to this one is going to be -1 would be the correct answer right there. Okay. All right, there's square root of -36. Remember, before we simplify, we always want to break this down into the square root of -1 times the square root of 36. Well, right there, we already have a solution. What comes out of that? I. What comes out of that? 6. The answer to that would be imaginary 6. All right, square root of -7. That's just going to equal, we'll extract the root times, well, that doesn't even have a solution, so we're only going to be able to solve that. So that's going to be I square root of 7 would be our answer there, because we can't do anything with that square root of 7. All right, then we have this one, square root of -32. Again, we want to extract the imaginary first times the square root of 32. And it's going to give us I times this. But then we can solve this out more. So we got to square factor that. What is that? Well, 4 goes into that, right? 4 goes into that 8 times. 16 goes into that. That's a bigger square that actually goes into that. So 16 times 2. So if we square root, we're going to get, that's going to come out to 4 square roots of 2. So that would be our answer. I, 4 square root of 2 would be the solution on that one. All right, here let's look at the square root of negative 36. This is example 2 on page 177. So what we're going to do here is we are going to always extract the root first, right? We kind of go back to this where I said that you're always going to extract the root before simplifying, okay? So let's go ahead and do that. Let's extract this root. So we want to extract the -1 first. We want to get the negative out of there. So that's going to equal square root of -1 times the square root of 36. Now we can solve this. And so this is going to solve out to, that's going to be your I, and that's going to be times 6. The square root of 36 is 6. Now notice it says something here in your book, and I want to pay attention to this. Write the I after the number, but before a radical or a variable. All right, so that's kind of just a little bit of a procedural thing. If you write it in a different order, it really doesn't matter. I think even in this lesson, I wrote it in a different order a time or two. It's really fine because it's the same thing. So if you look back here, we have I times 6. You could write that I6. But the proper way to write that is going to be to switch those. So 6I. I kind of like that and I kind of don't as a teacher because sometimes you could confuse that for an actual variable. You could say, oh, that's like 6x, right? So 6I could look like that if you don't write your I properly. So just be careful with that. Make sure you try to make it look like an italics I when you're writing it. Or, you could always write it like this too. It's not the end of the world. Some teachers that you get will throw a fit if you write it in the opposite order. But to me, it's multiplication. So it doesn't matter which order that you write that in. But I guess standard, all right, you're going to want to write it 6I, not I6. All right, so next we are on page 177, example 2. The second one that they give you is square root of -7. So that's going to equal the square root of -1 times the square root of 7. Well, you can't solve the square root of 7. There is no square root of 7. So this is just going to be I7, or better written 7I. That would be your answer. Next, the square root of -32 is going to equal the square root of -1 times the square root of 32. This is going to give us our imaginary, and then this one we have to further simplify. So you try to square factor that. What are some things that could go into that? Well, 16 is a square factor that goes into 32. So square root of 16 times the square root of 2. That solves out to 4 square root of 2. And so this is where you kind of go back to what it said on page 177. Let me show it to you again, where it says that write the I after the number but before the radical. So what's going to be the best way to write the solution to this one? We're going to write 4I, so after the number, but before the radical square root of 2. So that's what that one would look like right there. All right, next is example number 3. And this again is on page 177 still. So we have x squared minus 2x plus 5 equals 0. We want to go ahead and try to factor that. Probably, let me just, save us a little bit of time. You can't factor it, okay? So I'm going to actually complete the square. Maybe some of you like to do the quadratic equation better when you can't solve these. You can look at page 177, look at both of those. I like to complete the square, and there's a reason for that, because later in this book, we are not going to be able to use the quadratic equation. You're like, what? Yeah, you can't use it for certain things. You have to complete the square. So I'm going to go ahead and complete that square. If you remember how to do that, we take this middle term, okay, and we cut it. Well, first thing we do is we move this to the other side. So x squared minus 2x equals -5. We take this linear term, this 2, and we divide it by 2, and then we square that quantity, okay? So in this case, we're going to get 1 squared, or we're going to get 1. Now we have to add 1 to both sides. So add 1 and add 1. Let me change the color so you can see that a little bit better where I add the 1 to both sides. So this is going to be our new quadratic. X squared minus 2x plus 1 equals, and then we can just do that right there, and that's going to give us minus 4. And then we just go ahead and keep solving this out. Now we can factor it. That's the beauty of completing the square, is you're completing the square so that you can factor it. So we're going to go ahead and factor this, and it's going to give us a perfect square. We're going to get x minus 1 squared equals negative 4. Now what you would do is you would square root both sides, and that's going to cancel. We're going to get x minus 1 equals the square root of negative 4. You've never seen that before, right? Maybe in Algebra 2 you saw it a little bit. But you're like, wait, what's going on? Well, that's why we're learning this, because sometimes when we square root both sides, we get a negative number underneath the radical sign. And we haven't, up until this point, we haven't really known how to deal with this. So what we're going to do here is we are going to treat this like an imaginary number. So we can go ahead and solve this out. X minus 1 equals, and that is a plus minus when you get that too. So plus minus, and we're going to get the square root of negative 1 times the square root of 4. And we just kind of keep solving this out. We change the color again. X minus 1 equals plus minus. There's my I that comes out. And then what comes out of here is a 2. So we can switch that around to make that look a little bit better, because the book likes it the other way. 2I is what that looks like. And now we want to move this to the other side. We'll move this negative 1 to the other side by adding 1 to both sides. It's going to cancel here, add our 1 over here. X equals 1 plus minus 2I. And that would be our answer. Now, we could write it, x equals 1 plus 2I, and then write it again, x equals 1 minus 2I. That's fine. Or you can just use this plus minus sign. I think the book kind of shows it to you written both ways. Now, you might be wondering what this is because you've never seen that before. This is what's called a complex number. So let's go right down here, and this will be where I end this lesson, and then in next lesson we'll finish this this first lesson out. Complex number is any number containing both real number and imaginary number. Okay, so let's go back here, and we have, here's our real number. Our 1 was our real number, and then here is our imaginary number. 2I is imaginary. And so we have both real and imaginary. And this is the form that you put it in. Standard form of that is always A, or this is the A, that's the constant, so that'll be the number, right? So in this case, that was our 1. Okay, so 1 plus or minus, whatever it is, and then your imaginary number. And in this case, it was actually plus minus, so we'll write plus minus, and you can do that. So this could be a plus minus, or a plus, either one. And then you get 2I. And so that would be the standard form of writing our complex number. So we did write it correct up here. I just wanted to show it to you down here with the definition and with the standard form. Okay, so what I'm going to do is I'm going to go ahead and end the lesson there, and then we're going to come back and we're going to do the rest of the examples. Those are on page 188, and we'll finish that in the next lesson. I'll do example 4, 5, 6, 7, 8. Okay? All right, we'll see you later. That's all I've got for you. If you missed anything, please go back, slide it back, watch it again before you come back and watch the next lesson, so that way you'll know how to do these, hopefully. Okay? All right, that's all I got for you. Have a good one. We'll see you later. Bye-bye.